This is Harbin. Welcome to Video Notes 4.2, where we're going to talk about Coulombs law, formula writing for ionic compounds, and naming of ionic compounds. So let's see how we decide if a compound's ionic or not. You look for a metal or ammonium to start it, and then a nonmetal or polyatomic anion to end it. So look, the metal and nonmetal, yes, it's ionic. Metal and polyatomic ion, yes, it's ionic. Nonmetal, covalent. Okay. Polyatomic ion, ionic. Boom. Nonmetal, covalent. And then nonmetal, charge. So this is a polyatomic ion. It's not a compound because it doesn't have something to charge. Cancel that charge. Okay, so make sure you know that an ionic is a metal ion or ammonium to start and a nonmetal or polyatomic anion to end. And the positives and negatives must balance. So you see this name and you're thinking sodium, Na. You're thinking sulfide comes from sulfur, S. Then you check the periodic table, you find out sodium has a +1, sulfide is a -2. So when you put them together, you need 2 sodiums for every sulfide, so the chemical formula is Na2S. Boom! Look at that elephant. Okay, always charges. Some metals always have the same ionic charge. And those metals are group 1, or 1A, the alkali metals, group 2A, or 2, and aluminum always has a +3, zinc always has a +2, and silver always has a +1. So group 1 +1, group 2 +2, aluminum +3, zinc +2, silver +1, always the same charge. Why? They only ever lose the number of electrons equal to their charge. They get stable by losing that number and only that number. Group 1 only has 1 outer. Group 2 only has 1 outer. Aluminum has 3 outer electrons, and that's all it'll lose. Zinc and silver have those numbers of valence electrons that they lose only and always, every time. Nonmetals sometimes always have the same charge. Right? So memorize these two. These are the negatives. That group has -1, that group has -2, and this group has -3 for nitrogen and phosphorus. Okay? So the nonmetals make negative ions in 1, 2, or 3 electrons because filling their outer shell only needs that many. Only needs that many. Okay. So you have to use the periodic table and you have to find the elements that turn into ions from the periodic table and memorize the charges they need. Okay. So examples of writing ionic formulas. Look, it says calcium bromide, metal, nonmetal. Symbol of calcium, Ca. Charge of calcium, +2. Symbol from bromide comes from bromine, Br. Charge, -1. Okay, so I need 2 bromides to make sure my compound equals 0. Cancel the charge. Aluminum, Al. Oxide, O. Aluminum, +3. Oxygen, -2. Uh-oh. Hey, that doesn't equal. Look, now they both equal 6, so I need 2 aluminums and 3 oxide ions to make aluminum oxide. Okay, cancel charge. Writing names, metal, nonmetal. Write the name of the metal, potassium, and the name of the nonmetal, oxygen, but change the ending to IDE. Boom, you're done, because potassium always has a +1, so I don't need to do anything else. Metal, nonmetal. Sodium. And then nitrogen turns into nitride. Sodium's always a +1, done. Okay, so that's potassium oxide and sodium nitride. All right, if you want to write the formulas and names of compounds with polyatomic ions in them, you have to memorize your ions and use a periodic table. Sodium acetate, sodium Na acetate, C2H3O2 negative, +1 -1. Chemical formula is NaC2H3O2, done. Look, no charge when you're done because it equals 0. Magnesium, Mg, charge, +2. Sulfate, SO4, -2. +2, -2. You only need 1 of each ion. Boom, you're done. Aluminum, Al, +3. Because it's always a +3. Sulfite, careful, SO3, -2. And now we have to cancel the charge. So we need 2 of the aluminum ions. And make sure to put it in parentheses because you need more than 1 of the polyatomic. Ammonium, NH4 plus. I'm glad I memorized that. Carbonate, CO3 negative 2. So now I need 2 of those. Plus 2 minus 2. Get busy writing formula. NH4, 2 of those. And 1 carbonate. Boom, done. Okay. Look, it's a ionic compound. How do I know? No charge. A metal and a polyatomic ion. So I name the metal potassium. Hi, potassium. I name the polyatomic ion cyanide. Potassium cyanide. Don't eat that, kids. All right. Barium hydroxide. All right. So far, all of the metals I've run into have been ones that have an always the same charge. Okay, so write these rules down and follow them, or just follow them without writing them down, whatever it takes, peeps. So first you got to know that it's an ionic compound, and so you recognize the things in it. Write the charges, and then using enough ions, make sure that the charge is 0 overall. Use parentheses only to keep polyatomic ions together if you have more than one. And remember that there's no charges in the compound formula because there's enough of each ion to cancel that. Cancel that. Boom. All right. So what if you want to write the name of an ionic compound? Again, recognize. If you see metals or polyatomic ions in the compound, you know it's ionic. Write the name of the cation first, and the name of the anion second. And then look for Roman metals just in case. All right. So here's some examples. Metal, non-metal. Aluminum chloride. Aluminum chloride. Do I need a Roman numeral? No, because aluminum always has the same charge. It's a metal, and it's a polyatomic ion. So I'm going to name it sodium oxalate. What is this Roman stuff we're talking about? So when you see an ionic compound name, and it has a Roman numeral in it, it tells you the charge of the metal in that compound by using these Roman numerals. So I think we talked about this before, but just in case, you need to recognize all of those Roman numerals in case you see them in a name. Look at that! There's a Roman numeral in the name. So I know this is the symbol for iron. And then I look on the periodic table, and iron doesn't have the always charge. So this Roman numeral tells me it's +3. Chloride is Cl, and I look on the periodic table, and I know it's a -1. So I need 3 of those for every one of those. The chemical formula for iron 3 chloride is FeCl3. You write a formula by canceling the charge, like I just did. Boom. Okay. When you see a formula, though, you have to figure out the charge by undoing the formula. Okay. Kind of funny. All right. So here's some more names. Copper. It has a +2 charge. I don't even need a periodic table to do that. And then oxide, it's a -2 from the periodic table, so I know it's CuO. Right? Copper has a +1 charge. What? So copper could have 2 different ions because it's a Roman metal. And so I need 2 of these for every one of those. So I need 2 coppers and 1 oxygen. Potassium nitrite, K. Nitrate is NO3 negative. I don't have a Roman numeral in this because this comes from the periodic table group 1. Okay, lead 4 carbonate. Lead is Pb. 4 is the charge. Carbonate is CO3 negative 2. So I need 2 of the carbonates. So the chemical formula is lead, Pb, CO. Oh, look at that C. Who writes that? PO, Pb, CO3, 2. Done. Okay. All right. How do you name them? Well, again, you recognize metal, non-metal. Write the name of the metal. Write the name of the non-metal, change it into IDE, chloride. And then wait, you got to go back and look. This is a Roman metal. It doesn't always have the same charge. So to take this compound apart, 2 of those, 1 of those, this must be a negative. Oh, sorry, I said negative. Who does that? And +2 to make that equal 0. So the Roman numeral here has to be a 2. Cobalt nitrate. Write that. Cobalt nitrate. But wait, I need a Roman numeral because this is not an always metal. So I'm going to write CO because it's in there 1 time. I'm going to write NO3, NO3 because it's in there 2 times. Know the charge on that. So the cobalt must be a +2. Put it in. Okay. I'm going to do this one right here. Metal, non-metal. Write the name, iron. Write the non-metal with IDE, oxide. Do I need a Roman numeral? You betcha, because iron's a Roman metal. I have 2 iron in my compound. I have 3 oxygen in my compound. I know oxide is always -2. So this is -6 total. Right? So the iron must be a +6 total. How do I know? Because it had to equal 0. So this must be a 3, and that must be a 3. And I need a Roman numeral 6. Aluminum nitride. Aluminum nitride. Then I check. Whoa, I put an A. Totally eight. And so I have to look at the periodic table, and aluminum is an always +3, so no Roman numeral. No Roman numeral. Because aluminum is always a +3. We'll practice other ones later. All right, Coulomb's law. So you're wondering why some compounds dissolve and others don't. So we're going to talk about force of attraction or repulsion using charges. Okay. So if things have a small radius, it's a distance between ions or particles, and then this is a charge on one particle, that's a charge on another particle, and we have a constant to figure out the force of attraction or repulsion. To see if things will dissolve or not, we're going to use that. So ionic compounds have a high melting point because if they have a small radius, okay, then they have a high lattice energy, so it takes a lot of energy to melt them. Okay. Or the other thing is if they have a high charge, there's a +2 and a -2, strong force of attraction, high charge, and a relatively small radius, a little bit bigger than the sodium fluoride. So it has a high lattice energy and a high melting point. So the distance between the nuclei is the radius. And so you can see that sodium fluoride has a shorter distance than sodium chloride. So it's going to have a stronger lattice energy and a higher melting point. And the lattice energy has to be overcome to get it to melt. So if you look at this diagram, I like it. You can see that anything that's an ion, the ionic size is in red on all of them. So you can see that metals get smaller when they make ions, nonmetals get bigger. And then you can see the atoms. There's yellow, purple, and orange atoms. So you can see cesium gets a lot smaller when it makes an ion. Fluoride gets bigger when it makes an ion. Right? So ionic size depends on whether you're a metal or non-metal. So what does it mean? There's really 2 factors that influence bond strength. The smaller the ionic size, the closer the ions are to each other and the stronger the bond. The higher the ionic charge, the more attraction there is between ions, so the stronger the bond. Okay. So we're going to use Coulomb's law to help us decide if things will dissolve in water. So they will dissolve soluble in water if the attraction of and for water is stronger than the attraction of the ions for each other. So when Coulomb's law formula multiplies to a total of less than 4, then it's going to be soluble. Yep. Ionic compounds do not dissolve in water when the attraction of ions is stronger than the attraction of water. So they're going to be insoluble when Coulomb's law formula multiplies to 4 or greater. We'll practice that in class. So to review, memorize your ions. Always metals always lose the same number of electrons, so they always have the same charge. Group 1, group 2, aluminum, silver, zinc. Roman metals roam around with their charge, so you have to have a Roman numeral to tell you the charge. You're writing a formula, cancel charge. You're writing a name, cation round first, and a Roman numeral if you have to, and then name the anion. Use Coulomb's law, multiply charges for solubility. Okay, it's been fun. Hope you learned.